Hello, this is Gary. Welcome to week 2 in quantitative literacy. This week, we're going to play more with scientific notation and the ratios of numbers that we were talking about before, like what percent of this number is that number, or, I have 50% more face-to-face students this quarter, or online enrollments are up 30%, things like that. And we're going to do that in the water footprint section and play with scientific notation in the algebra and scientific notation section here. So let's take a quick look at a couple things in lesson 1.3, tutorial video at the top you should check out. Not a bad idea. Read through what's expected of you here. There are examples. Reminder that to multiply on a computer, we have to use the asterisk key or press the appropriate button on the calculator. And that just kind of depends on the scenario. The idea of asterisk for multiplication was gone over in our prep intro to lessons. So information above talks about expression, equation, or inequality. Not too bad. A little bit of playing with exponents. That's going to be helpful for scientific notation. And I think I just hit the wrong button somewhere. Didn't mean to hit that button. I'm on that one. And powers of 10, it's possible to have negative exponents. Again, you're going to read through that in the lesson. And what I want to play with here is a little bit of scientific notation stuff. And remember, to enter something in scientific notation, there can be only one digit to the left of the decimal point. So this number would have to be 8.150. And then we multiply. How do we multiply on a computer? Asterisk by 10 to some power. And the power is going to be the decimal moved 1, 2, 3 places. So that would be the scientific notation version. If you're not sure, sometimes a calculator can be enlightening. So I love Desmos Scientific. So if I type 8 point, what was that again? 15 raised times, 10 raised to the power 3, I should get that same number, 8,150. Now, sometimes the number is going to be too big to display in regular notation. So if I had something like 3.14 times 10 raised to the 18th power, the computer's just going to give it back to me in scientific notation because it doesn't have enough room to write it in regular notation, which is kind of a benefit sometimes. All right, let's see. And if it's not strictly in scientific notation, but kind of like scientific notation, that's called pseudoscientific notation. Here's another video here for your enjoyment. Please check it out at the end of that third page. What I want to play with is some of these more complicated ones. And so I'm going to take a look at these two right here real quick. And let's see, we need a screenshot of that sucker. Can't see two things at once. Take a screen selection shot. And it's a good idea to, anything you put in your calculator, put it on paper first. So I recopy what I see on the screen on my paper. And here, I just got a whole bunch of multiplications. Multiply, 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 multiply. And you can multiply in any order you want. So I could say this is also the same as 4 times 5 times 10 to the 5th times 10 to the 6th. And earlier in this lesson, there was a rule that if you multiply things with the same base, you keep the base and add the powers. 4 times 5 is 20. So now I have 20 times 10 to the 11th, which kind of looks like scientific notation, except there are 2 digits to the left of the imaginary decimal place there. So this is what they call pseudo-scientific notation. So what I really want to do is rewrite that. Well, there's a couple ways to do it. You could expand this out, or you could just clean up this part and then combine it with that part. So I'll do it both ways. So if I just focus on this part in a minute, to put 20 in scientific notation, that would be 2 times 10 to the 1st. Then I have to multiply that by a 10 to the 11th. So those two together, keep the base, add the powers, I get 2 times 10 to the 12th. Alternatively, you could just list out all those zeros So there's my 20, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. Count them again, make sure you get them right. I'm gonna throw some commas in there. Help me count it. All right, so I get 3, 6, 9, 12. So if I want the decimal to go there, it would be 2 times 10 to the 12th. Could you call it 2.0 times 10 to the 12th? Absolutely, that would be okay too. And you can just type that into a modern calculator. So let's do it calculator-wise. So calculator-wise, I've got 4 times 10 raised to the 5th. And then I have to arrow out of the power, either with the arrow on the keyboard or the arrow on the calculator. And then I want to multiply that. And you could use parentheses like it did, but with multiplication, the parentheses are optional. Times parentheses 5 times 10 raised to the 6th. Arrow out, close parentheses, and the calculator gives me scientific notation. If I wanted to do one that had division in it, we could do it with or without a calculator. Let's get a screenshot. Actually, I can just move it over and copy it by hand. Boom, boom, boom. All right, so my other problem had 4 times 10 to the negative 6 divided by 8 times 10 to the 9th. Cleaning that up, I could rewrite it as 4 over 8 times 10 to the negative 6 over 10 to the 9th. Well, 4 over 8 is a half, and a half could be 0.5. And the rule for dividing things with the same base is keep the base and subtract the powers. That would be negative 6 minus 9. So if I lose 6, then I lose 9. Altogether, I've lost 15, so that'd be 10 to the negative 15th. All right, problem, this is not scientific notation because that's not, it's got to be a non-zero digit over there. So I have two options. I could either write this out, moving the decimal 15 times to the left, or I could just rewrite this number. So if I put that in scientific notation, this is the 10th position right there. So I could write it as 5 times 10 to the negative 1, because 10 to the negative 1, as you learned earlier in this lesson, is the 10th position. And if I take that times 10 to the negative 15th, here I'm multiplying things with the same base. So I add the powers, negative 1 plus negative 15 would be 10 to the negative 16. So in scientific notation, this would be 5 times 10 to the negative 16th. And this right here is not scientific notation. That's that pseudo scientific notation, because there has to be a one non-zero digit to the left of the decimal point, which I now have right there. Similarly, you could type that in your calculator. So I recommend Desmos. If you're not using Desmos, you might need parentheses around the numerator and the denominator. I'll look at both ways. Let's see, Desmos. All right, so typing that, I would start a fraction, and then I have 4 times 10 raised to the negative 6th divided by, arrow down, 8 times, which I'm using the asterisk on the keyboard, and the computer sees it as times, or you could click the times button, 10 raised to the 9th. And you might notice I haven't clicked the power button here. Instead, I'm using the caret, the hat key, Shift 6, to say, give me a power. But hitting that button will do the same thing. So again, I could type 10, hit that button, and then type my power. Or I could type 10, Shift 6 to put in the power position, and then type my power. And either way, the calculator says, oh, I'll give you that in scientific notation, because it was too wide to display without scientific notation. Beautiful, isn't that awesome? Okay, other things that you're going to play with in this week's lessons are comparing large numbers. So you're going to do the, oops, I want this one here, water footprint. And there's a online water footprint calculator you're going to run through the prep. And then we've got this lesson here. And let's reset and start it. Again, read through the intro stuff. It is important. I'm just giving you a quick summary. Here we get some information about the United States population and Earth's population. So we're going to state them in scientific notation, and then we're going to compare them. And the order that they're stated is the order of the comparison. So let's see, write a ratio comparing the US population to the world population. So in this case, US to world. Let's do that. There we go. Notebook. So this is lesson 1-4, just a quick note. We want to compare the US to the world. So fraction-wise, that puts US in the top and world in the bottom. So the US was, let's see if I do it in scientific notation, that would be 3.17 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 divided by the world, which is 7.2 billion. Billion would be 10 to the 1, 2, 3, 4, 5, 6, 7, 8, ninth. And I could just type that into my calculator. Alternatively, you could write them out as regular numbers. Like, what was it? It was 317 million versus 7.2 billion. So I would go 7, comma, 200, and then keep adding zeros. That's millions one more time until I get billions. And again, I can just type this into Desmos as I see it. This one's fun on paper because then I get to cross stuff out, which I love, like divide by 1,000 top and bottom, divide by 1,000 top and bottom again, or you could have divided by million top and bottom, which would do that. So then on my calculator, I could say, okay, what's 317 divided by 7,200? And that would be that comparison. Let's see what it is on a calculator. 317 divided by 7,200. My calculator says that that is 0.044. Let's write that down. So I'm rounding that. So I'm going to put a wavy equals 0.044. And remember, to convert a number to a percent, we could multiply that by 100%, which shifts the decimal twice. So that would be about 4.4%. So this tells me that the population of the US is about 4% of the world population. Cool. That's the stuff you're going to have fun with this week. Keep up the good work. Write to me when you get stuck and do good math. Over and out.